Why is this floating city, the icon of the seas, shattering every record in maritime history? And how does its complex network of 20 decks manage to accommodate a population larger than most American small towns, right in the middle of the unforgiving Atlantic? But the most important question is, how does it survive? How do they generate enough fresh water to keep 7,600 people hydrated, showered, and sliding down water parks when surrounded by nothing but undrinkable salt water? And perhaps the darkest secret of all, what happens to the 2,000 tons of trash produced here every single week? Does it just vanish, or is there something far more complex happening beneath the waves to prevent this vacation spot from becoming a floating landfill? More detail all in the video ahead. The icon of the seas was built at a staggering cost of $2 billion and is the largest moving structure ever made by man. How big? Well, for comparison, the legendary Titanic looks almost like a mere lifeboat next to this behemoth. But the icon's sheer size is much larger than anything we have seen before. Let's break it down further. From the outside, it looks like a floating paradise, a colorful playground designed for luxury. But strip away the paint, and you find a roaring industrial machine. A hidden underworld of pipes, crushers, and reactors working 24/7. While the passengers sleep in comfort above, a steel beast below is fighting a constant war against salt, waste, and physics just to keep the lights on. This massive difference in scale gives the icon an advantage, but it also creates a logistical nightmare that no other ship has ever had to solve. The icon of the seas tips the scales at around 250,000 gross tons. How big? Well, for comparison, the legendary Titanic looks almost like a small fishing boat next to it. While the Titanic was an engineering marvel of its time, the icon is 5 times larger by volume. Let's break it down further. The icon towers 20 decks high, standing taller than the Statue of Liberty. If you stood it up vertically next to the Eiffel Tower, it would hold its own against the Iron Giant. These decks or layers span from the waterline to the top of the superstructure, showing a significant leap in maritime engineering. This size difference gives the icon an advantage that goes beyond just bragging rights. It allows the ship to be divided into 8 distinct neighborhoods. While an aircraft carrier has a flight deck and a hangar bay, the icon has a central park with over 12,000 real plants and trees and a thrill island with 6 record-breaking water slides. To give you a better idea of how the icon manages this floating population, think of it less like a boat and more like a vertical city. Movement is key. The Ford-class carrier uses massive elevators to move jets. The icon uses a smart destination elevator system to move thousands of humans. These aren't just standard lifts, they are the arteries of the ship, calculating the fastest route to shuttle hungry passengers from the lower stateroom decks to the upper dining levels, reducing the chaos of rush hour in the middle of the ocean. This immense area allows the vessel to accommodate up to 7,600 people at maximum capacity. That is the population of a small American town, all packed into a moving steel island. It is effectively one of the largest moving structures ever built by human hands. But maintaining a population of this size in the middle of a saltwater desert presents a terrifying problem. With 20 swimming pools and thousands of showers running simultaneously, where does this city get its fresh water? But what makes the icon of the seas truly revolutionary is its life support system, designed to conquer the one thing the ocean has plenty of but humans can't drink: salt water. The ship relies on a sophisticated desalination plant that works 24/7 to turn the Atlantic Ocean into crystal clear drinking water. To help you understand how it works, let's walk through the process. Massive intakes suck in seawater from beneath the hull. This water is then pressurized and forced through microscopic membranes in a process called reverse osmosis. Think of it like a coffee filter, but on a molecular level. The salt molecules are simply too big to pass through, so only pure, fresh water comes out the other side. This water is then remineralized and piped directly to every tap, shower, and pool on board. This system produces over 400,000 gallons of fresh water every single day. That's enough to fill an Olympic-sized swimming pool every 24 hours. But hydration is only half the battle. With 7,000 people eating, drinking, and living on board, there is another problem that most people don't want to think about: trash. Every week, this floating city generates tons of glass, plastic, and food waste. You might wonder, do they just dump it overboard? The answer is a hard no. Instead, they use a cutting-edge technology called MEDAGS, or micro-auto-gasification system. Here's the most important part, and the reason this ship is a game changer for environmental standards. The waste is not burned, it is thermally disintegrated. The system heats the trash to incredibly high temperatures in a low oxygen environment, breaking it down into a synthetic gas. This gas is then used to power the system itself, creating a self-sustaining loop. What's left behind is not a mountain of garbage, but a small pile of harmless, sterile biochar, roughly 5% of the original volume. This advancement makes the icon of the seas not just a vessel of pleasure, but a self-contained ecosystem designed for efficiency and minimal impact. However, all this technology is useless without the people running it. And this is where the American dream meets the reality of life at sea. Managing a city that never sleeps requires an army, and their battlefield is the lower decks. During dinner service, the main galley is considered one of the most intense workplaces on the ocean. Together, the culinary team must plate and deliver roughly 10,000 meals in a span of just 4 hours. But wait, the margin for error here is razor thin. If a steak is overcooked or a soup arrives cold, the illusion of the perfect vacation shatters. So, just like a flight deck coordinating jet launches, the kitchen operates on a strict military-grade rhythm. The executive chef acts as the air boss, overseeing a brigade of hundreds of cooks, chefs, and expeditors. Orders are fired into the system, creating a digital stream of data that directs every chop, sear, and garnish. To prevent chaos, the galley is divided into specialized stations, each functioning like a pit crew. You have the cold larder, the hotline, the bakery which operates 24/7, and the dishwashing pit, which battles a never-ending mountain of china and silver. But how do the supplies get to these kitchens without the guests ever seeing a single pallet jack? This is where the Icon's secret weapon comes into play. Just below the passenger decks lies a hidden superhighway known to the crew as I-95. This is a massive, industrial corridor running the entire length of the ship's hull. It is the central artery for logistics. Here, electric forklifts and trolleys zip back and forth, moving tons of flour, fresh produce, and luggage. It is loud, it is busy, and it has its own traffic rules to prevent collisions. Adjacent to this highway are the provision rooms. These are not just pantries, they are massive warehouses cooled to different temperatures to preserve supplies for weeks. You have a room just for beer, a freezer the size of a house for ice cream, and a dry store that holds enough rice to feed an army. The logistics are mind-bending. Every Saturday, during the few hours the ship is docked, they must load unmatched quantities of fresh food while simultaneously offloading tons of recyclables, all before the next 6,000 guests board the gangway. But this floating city needs to sleep, and the crew that powers it is spread all over the lower decks. The Icon of the Seas is home to 2,350 crew members from over 80 different countries. Beneath the waterline, away from the balconies and ocean views, you will find the crew cabins. These quarters are tight but efficient, often shared by 2 people with bunk beds and small lockers. But what's even more unbelievable is that the crew has their own parallel society hidden inside the ship. They have their own dining halls, known as the crew mess, which serve food from around the world to comfort the international staff. There is a crew bar where they socialize after a long shift, a dedicated gym, and even a mini supermarket called the Slop Chest, where they can buy toiletries and snacks at their own will. Just like the aircraft carrier has designated areas where pilots rest before a mission, the Icon provides these spaces to keep morale high. Because a tired crew makes mistakes, and out here, mistakes can be dangerous. Moving further ahead, the bridge officers monitor the ship's vital signs. But the real security comes from the seamless coordination of the technical teams. Just below the waterline, engineers are constantly monitoring the stabilizers and hull integrity. This is the nerve center of the ship's safety. For example, when a storm approaches, the captain and his crew don't just steer the wheel. They utilize a dynamic positioning system that uses the ship's thrusters to hold its position or navigate through rough swells with pinpoint accuracy. This automated process requires much less manual correction compared to older cruise ships, making the Icon class much more effective at neutralizing the impact of waves, ensuring that the guest's drink never spills, even in a gale. But to push a structure of this magnitude through the water at 22 knots requires a heart of absolute power. A propulsion system so advanced, it doesn't just turn a propeller, it changes the future of naval energy. While the Gerald R. Ford-class aircraft carrier relies on nuclear reactors that act like a miniature sun, the Icon of the Seas harnesses a different kind of beast. It runs on liquefied natural gas, or LNG. Think of it as the cleanest burning fossil fuel available, drastically reducing emissions compared to heavy marine diesel. To help you understand the scale of this power plant, let's look at the process. Deep inside the hull, 2 massive cryogenic tanks store fuel at -260 degrees Fahrenheit. At this temperature, the gas becomes liquid, shrinking its volume by 600 times. This is how it works. Step 1, the liquid fuel is pumped into vaporizers. Step 2, it transforms back into gas, effectively becoming the dragon's breath that feeds 6 colossal engines. Step 3, these engines generate over 67 megawatts of electricity. Yes, you heard that right. 67 megawatts. That is enough power to keep the lights on in a city of 50,000 people, run the massive air conditioning units, filter the water for the pools, and still have enough juice to spin the 3 massive azipods. These azipods are electric propulsion units that hang beneath the ship, capable of rotating 360 degrees, allowing this 20-story building to turn on a dime. But the engineering doesn't stop there. The ship literally rides on a carpet of air. Using a system called air lubrication, compressors pump millions of microscopic bubbles along the bottom of the hull. This reduces friction between the steel and the water, making the ship glide more efficiently, saving fuel and further protecting the environment. When you step back and look at the icon of the seas, you don't just see a cruise ship. You see the pinnacle of civilian engineering. It is a testament to how far we have come in mastering the elements. From converting the salt ocean into fresh water, to turning waste into energy, and using cryogenic fuel to power a floating metropolis, this vessel is a prototype for the future of human living. This engineering marvel proves that we can build self-sustaining cities on the water, pushing the boundaries of what is possible. It is a complex ballad of logistics, physics, and human determination, all hidden beneath a veneer of water slides and luxury suites. If you enjoyed this deep dive into the mechanical heart of the world's largest ship and want to see more breakdowns of the mega machines that shape our world, consider subscribing. We are building a library of exclusive engineering animations just for you. Let us know in the comments which massive structure you want us to dismantle next, perhaps the world's largest airport or the deepest underground bunker. Until then, keep exploring. Ultimately, when you strip away the neon lights and the water slides, the icon of the seas stands as an unparalleled triumph of civil engineering. It is not merely a vehicle, it is a prototype for the future of human habitation. We have managed to take a population the size of a small town, place them in the middle of the hostile Atlantic, and keep them alive, hydrated, and comfortable using a self-contained grid of power and purification. This ship proves that with the right application of physics and logistics, we can build self-sustaining ecosystems anywhere on the planet. The technologies tested here, from the air-lubricated hull to the waste to energy conversion systems, are the stepping stones toward true floating cities. It challenges us to rethink our relationship with the ocean, moving from simply traveling across it to living sustainably within it. We pour hundreds of hours into creating these original 3D animations to help you visualize the invisible systems that run our world. We are a small team of creators, so please support us by subscribing and hitting the notification bell. It is the best way to ensure you don't miss our next deep dive. And speaking of deep dives, we want to hear from you. What massive structure should we dismantle next? Should we explore the complex baggage handling systems of the world's largest airport, or perhaps the life support systems of a nuclear submarine? Drop your suggestions in the comments below. Thank you for watching, and we will see you in the next engineering breakdown.